Welcome back, students. We are now down to the topic 3 of this course, the GE 102 Geometric Geodesy. So, topic 3 consists of two parts, no? And in this lecture or in this video lecture, we are going to discuss the part 1 of the topic 3, which is all about geodetic positions and measurements in the reference ellipsoids. This is for the authors and contributors of these lecture materials. And here is for the copyright notice. For this topic, we are going to discuss about XYZ Cartesian coordinate system, geodetic coordinate system, geocentric coordinate system, the meridian ellipse and parametric or reduced coordinate system, and the relationship between the various latitudes. This is for the intended learning outcomes. After this lecture and exercises, you, the student, must have explain the concepts of positions on the surface of the ellipsoid, illustrate and explain the different coordinate system in the reference ellipsoid and their components, differentiate Cartesian coordinate system, geodetic coordinate system, geocentric coordinate system, and parametric coordinate system, illustrate and differentiate the different types of latitude in the reference ellipsoid, illustrate and explain the relationship between the various latitudes, memorize the formulas necessary to calculate Cartesian, geodetic, geocentric, and parametric coordinates of points in a reference ellipsoid, calculate Cartesian, geodetic, geocentric, and parametric coordinates of points in a reference ellipsoid, solve problems involving the different coordinate systems in the reference ellipsoid. Before we start the discussion about this topic, we are going to recall first all about latitude and longitude. Here are some facts about latitudes. The lines of latitude runs horizontally. They are also called as parallels. Latitude is measured in degrees, and the equator is 0 degrees latitude, and the lines of the latitude locates the places of the north or south of the equator. And the North Pole is the 90 degrees north latitude, and the South Pole is the 90 degrees south latitude. So here are the facts about longitude. First is the lines of longitude is run vertically. They are also called meridians. The prime meridian is found in the Greenwich, England, and the prime meridian is the 0 degrees longitude. Lines of the longitude locates the places of the east or west of the prime meridian. And lastly, there are 180 degrees of east longitude and 180 degrees of west longitude. So let's start with the X, Y, and Z Cartesian coordinate system. So basically, the origin of this system is situated at the center of the ellipsoid. For example, ang iyahang point O or the origin is na siya sa 0, 0, 0 nga coordinate, which means to say that is the X, Y, and Z. So na siya sa center sa ellipsoid. And z-axis coincide the minor axis. Na siya, mo ni si z-axis. So ni coincide siya sa tuang minor axis, no? Where ang x-axis and ang atuang y-axis is na coincide siya sa tuang major axis. And the equation of this surface of the ellipsoid is like this one. So basically kaninga equation or kaninga formula is gikan lang gyapon siya sa katulad atong discuss last time sa atuang previous topic nga about the ellipse, no? Equation of general equation for the ellipse. So ito lang siya gikan, pero ang nagkalainan lang is nanay since katulo man siya ka axis kay dimensional naman siya. So si x ug si y, no, for this example or for this figure, si x and y axis coincides with a major axis, mo na duha sila, no? Si x squared plus y squared over a squared kay since sa tuang figure, no, si x axis and si y axis is ni coincide siya sa tuang major axis, while si z axis or si z squared or ni coincide siya sa tuang minor axis, which is ang b. So mo na ang iyahang equation na, no, x squared plus y squared over a squared plus z squared over b squared minus 1 is equals to 0. Alright, so more discussion about x, y, and z coordinate system. So looking at the top view, no, baliktaan nga figure, since kay we're going to have our perspective on the top view or in the North Pole, no? Ato i-consider na to aning ice kani. Ito na hunahon nga kamuna na tan-aw dira sa taas, no? The North Pole. So here in our figure, we have point P, no? Kani nga part. So that's point P. And we have here the z-axis, the x-axis, and the y-axis. No. So since kay top view man ta, so atong makita is only two-dimensional. No. So sa atong makita kani, no, ellipse gyapon or yes, ellipse gyapon. So from top view mo nito makita, no. So, we have here the axis, first axis. This is the x-axis, and this is the y-axis. And since kinamantay point P, so naadira nga part si point P. Kaning nga point nga nigipakita is mo na siya si point P. Point P ato nang imbutangan de. Sige ato nang imbutangan. Big letter P na siya ha. Big letter P. And there is a line that will connect, no, from the center of the ellipse going to the point P. So, ang tawagan na niya class is radius of the parallel, no? Or that is denoted as small letter P. Small ni nga P ha. Yeah, small letter P. So, if that will going to be connected, no? So, atong i-consider, no, from this figure, no, nga kani nga axis kani, di ba kay x-axis na siya, so dira mag-start ang ato ang zero meridian or the prime meridian. So from the prime meridian padulong sa imuhang padulong sa meridian sa katong gusto nimo i-locate or the point P, no. So from the prime meridian going to the meridian sa imong gusto kuhaan or gusto nimo i-locate nga point or kaning gitawag nato nga point P, no. So ang tawag ana niya class is from this figure, no, at the right side, that is longitude, no. So kung longitude na siya, if we're going to get the x-axis, ang x-axis ani niya sa point P kani, no, and the y-axis is kani. Ako na lang sorry kay hiwi. Okay, so kani si x-axis, kani si y-axis. Therefore, we can say nga si x-axis is just radius of the parallel times the longitude, and si y-axis is radius of the parallel or si P sine longitude. And to get the radius of the parallel or small letter P denoted as a small letter P, that is equal to square root of x squared plus y squared. Let us all recall that the ellipsoidal coordinates includes the latitude, longitude, and the height. From this figure, no, si latitude rather is from the equator padulong sa parallel, no, parallel or sa latitude sa place nga imuhang gusto kuhaan of location or the point that you are going to locate, no. For this example, this one, no, so yung latitude rather is from the equator padulong sa latitude, no. Muna siya si latitude. And for longitude is from zero meridian or the prime meridian going to the meridian of your place na gusto i-locate, no. And height, no, is from the ellipsoidal or say h, no. So si h is ellipsoidal height, and it was determined from the surface of the ellipsoid padulong sa topography sa Earth. Okay, since ang topography sa ato ang Earth or ang terrain sa ato ang the terrain of the Earth is not always coincides with the ellipsoidal surface. Because we all know, no, sa atong previous discussion that there are different surfaces of the Earth. We have ellipsoidal, the geoidal, and Earth's topography or the Earth's terrain. So, na siya height nga gi-introduce, no, para na ay relationship ang Earth's topography to the geoid and geoid to the ellipsoid surface. So in this case, H itong gigamit, which is ang ellipsoid case, since we are dealing with the ellipse surface. No? So the height is from the surface of the ellipsoid going to the Earth's topography. But in the case of latitude, natay klase-klase nga mga latitude na what they call this one, introduce, no, after this slide. It's because we have geodetic coordinate system, geocentric coordinate system, and we have also reduced coordinate system. And magmatter na sila or magkalahi lang or magka-different na sila. Makita na to ang ilang differences because of their derivation of the latitudes. Alright, so the first latitude nga to ang i-discuss is si geodetic latitude. Again, class, this is very important in this topic, no, to know or to mailhan na to sila, no, nga kung kinsa sila, no. And one way to know different kinds of latitude is through their Greek letters, no, or ilang denotations. Na pag makikita ang geodetic latitude, kani ang iyang denotations, or pwede po siya ingani, no. Depende sa inyo kung sa gusto. Basta kay pag inga nagporma, no, pag inga na ang Greek letter nga gigamit, therefore ang pasabot na niya is geodetic latitude. It's because important na siya, class, labi na unya pag derive na to sa ilahang mga formulas and how to get their relationship between different latitudes. So mas dali na to sila determine or dali na to sila masabtan, no, or mailhan. So much for that. Geodetic latitude is the angle between the normal to the ellipsoid at a point, no, normal to the ellipsoid at a point and the equatorial plane. No, when we say normal, class, it means to say 90 degrees na siya, no, at the specific point. So to visualize, so we are going to deal this one, class, nga nata sa side view sa Earth, no, side view sa Earth. So therefore, kung nata sa side view, two-dimensional na itong makita, so makakita taog ellipse. And we have here the axis, kani siya nga axis, okay, since side view man ta, so this is the z axis, no? And the other axis is side view man ta, so si x axis na siya, class, no? Si x axis. So ang pasabot ni geodetic latitude, class, is nado tay point, no? There's a point, and normal daw ana niya nga point, pasabot 90 degrees ana niya, class. So naatay kung may tag 90 degrees makuha or maka-draw ta og 90 degrees pag naay tangent line ana niya, class. No. Tangent line nga kas alang nag-touch na sa surface sa Earth. No. And 90 degrees kay normal may pasabot, no, normal to the ellipsoid at a point. So pasabot 90 degrees ana niya. So magbuhat ta og 90 degrees. Yan. Ang pasabot ni geodetic latitude is the angle between the normal to the ellipsoid at the point, so kani, no, and the equatorial plane, which is kani. So therefore, ang atuang geodetic latitude, class, is kani nga angle, no. That is the geodetic latitude. No? So since kay 90 degrees man ni siya driya, class, no? 90 degrees na siya, tapos kani is geodetic latitude. Therefore, the value of this outside, no, nga angle, no, exterior angle niya, class, is equal to 90 degrees plus the latitude or geodetic latitude. Nagets na ninyo? So I guess nagets na ninyo na anong 90 plus na siya dira, 90 plus geodetic latitude. Next is the reduced latitude, and it is denoted as this Greek letter, no, beta. So for definition, it is the angle at the center of the sphere that is tangent to the ellipsoid along the equator, between the plane of the equator and the radius to the point intersected along the sphere by a straight line perpendicular to the plane of the equator and passing through the point on the ellipsoid. To visualize the reduced latitude, first is we are going to have the ellipse, no? Since ellipse ang ato ang gigamit diri. Then sa reduced latitude, natok dito ang ana daw siya sphere, no? And tangent to the ellipse going to the center of the sphere. So dapat naapod tay sphere, no? So from that sphere, then natay z-axis and naapod tay x-axis, no? So from the point there, no, padulong daw sa center sa sphere, no, point on the sphere, padulong sa center sa sphere, tangent to the ellipsoid. So sabot sa tangent, kas lang siya nag-touch, no, sa ellipse. Ano siya nga part. And from the plane daw of equator, so therefore diri gikan padulong daw sa radius, no, nga nag-contain sa point and also tangent to the ellipse, so therefore kani, no. So ang ato adi ay reduced latitude is kani nga angle. Ano to siya? Alright, kani. So kani nga angle is ang reduced latitude. So ang pasabot lang sa reduced class, di ba atong gikuha ang basis is ang sphere, no? Since kay ellipse man ato ang gi-consider, no? So therefore atong i-reduce from sphere, ato siyang i-reduce into ellipse. So ato lang gibaba, no? Murag ato siyang gi-project going to the point on the earth, no? As a ellipse, no, nga surface. So nga na lang basically ang concept sa reduced latitude. Another one is the geocentric latitude. So for geocentric latitude, ang denotation na po niya class is kani nga Greek letter. So again, dumduman ninyo na ha, kay para dali na lang sa pagsabot ninyo later sa derivations, no? For geocentric latitude, it is the angle at the center of the ellipse, no? Ang reduced kay center of the sphere, no? Ang tangent, ang reduced latitude, di ba kaganina, is from the center of the sphere tangent to an ellipse. So for geocentric, largo na siya, center of an ellipse between the plane of the equator and the line of a point. So for illustration, we have here an ellipse, no? And we have the z-axis. We have also here the x-axis and the point, no, nga gusto nato siya kuhaan og locations. Kuhaan nato og geocentric latitude. And padulong do siya sa center sa ellipse, no? And the equator, no? From the equator or between the plane of the equator and the line of the point. So kani ang line of a point, kani ang equator. Therefore, ang geocentric latitude pala is kana nga kani siya nga angle, no? So kana lang for geocentric latitude. Alright, so para mas ma-differentiate pa na nato ang tulo ka latitude, which is ang geodetic, parametric or ang kanang gitawag na to reduced latitude, and the geocentric latitude, is ato silang ipatong-patong. Green-minded is not allowed, no? So to differentiate between those latitude, so we have this figure, no, balik ta na sphere kay since nagtakal-takal na og sphere, and we have also ellipse, no, and we have this axis, what we call the z-axis, and this one is the another axis pala is the x-axis. So we have also here the point or the location in the some part of or some point, no, of the earth nga gusto nato siya i-locate. So first latitude or first figure, no, nga atong i-differentiate is ang kani, no, from the point of the ellipsoid, no, padulong siya sa kani nga line, no, which is normal to that ellipsoid, no. So na-reduce diha dapat normal siya at the point, no, sa ellipse. So therefore, to have a normal which is 90 degrees, dapat magbuhat ta diha og line, no, which is tangent to that point, tangent to that point, para makabuhat ta og 90 degrees. No? From that 90 degrees, ani nga tangent line, mao ni siya, no? Kani siya nga radius or kani nga line. So therefore, kisa man ni siya nga latitude, kaning gikan sa equatorial padulong diha sa radius of the line, no, that is normal to the ellipsoid. So kana siya nga latitude is what we called the geodetic latitude. So kana nga denotation. Another line or another radius that is largo na sa center sa ellipse. From the point we have here radius going to the center of the ellipse. So gikan sa equator padulong diya sa radius which is directed to the center of the earth, ellipse pala rather. So kana siya nga latitude is what we called the geocentric latitude. And lastly is the radius from the sphere, from the sphere going to the center of the sphere. From the point of the sphere going to the center, that is tangent to the ellipsoid. So kani nga point diri nga part, so tangent siya kay kas ara siya nag-ikot. So sikinsa man na siya, again from the equator padulong anang radius which is going to the center of the earth and is tangent to the ellipsoid, So kaning latitude is what we called reduced latitude. So sa reduced latitude class, point on the sphere, i-project lang niya padulong sa ellipse. So kaning lang. So therefore, ang coordinates ana niya nga nasa sa sphere is na siya diri kani gyapon niya point. So mo na siya ang differences between the three para na lang may murag somewhat like ma-differentiate ninyo ba through illustration. So inga na ang differences between three latitudes. So please take note of these important facts about the three latitudes, that the geodetic latitude is must be greater than or equal to reduced latitude, and reduced latitude must be greater than or equal to the geocentric latitude. So from three latitudes, it is always mas dako gyud si geodetic compared to reduced, and si reduced is mas dako always compared kang geocentric. And kung si geocentric with respect to geodetic, mas dako si geodetic. Let's go now for the derivation of the geodetic coordinate system. So let's go back to this figure from our discussion in the previous slides. Kung nadiri mao ni siya si geodetic latitude, and we have here the value of 90 plus theta. So mo-agree mo na therefore it's because this is normal to the ellipsoid, so 90 degrees na siya diha. So the value of the external angle is 90 plus geodetic latitude. And if we have here the value of 90 plus geodetic latitude, so the value of this one would be pila man? So that is 90 degrees minus geodetic latitude, right? So here's another representation on how to visualize the geodetic latitude. So we have here this is the geodetic latitude, and this is 90 degrees diri nga part. Alright, like a color. So 90 degrees, and if you're going to extend this one here, assuming a straight na siya class, kamo lay visualize. So kani di ba nga angle is kato ang gi-discuss nga 90 plus geodetic latitude. So kani diri is 90 minus geodetic latitude. So same ani okay, since the law of the geometry applies so nganong 90 minus theta. So again, para mas masabtan ninyo, mag-draw pa diri og line, and another one is mag-draw pa diri og line. Dapat nag-abot na sila. So kung the law of the geometry applies, so kung this is theta or geodetic latitude, therefore kani siya diri is geodetic latitude, and this one is the 90 degrees. So nganong 90 minus theta, no? As you can see, diri ang part, no? Kung ato ning i-extend ito, 7. Yan. So this is also 90 degrees, di ba? So kung 90 degrees na siya, kung naa kay theta diri, naa kay theta or geodetic latitude diri, 90 degrees man ni siya. So therefore ang mabilin is 90 minus theta. Alright, to start, we are going to derive now the equation for the geodetic coordinate systems. So first, let us recall the equation of an ellipse based on our discussion from the previous topic, no? Which is x squared over a squared plus z squared over b squared is equals to 1. So kung nagmutanang mo nganong z squared na diha sir kani, nganong z squared naman ni sir, na y squared ba na dito asa ato ang discussion from the previous topic. So let us recall, no, from the previous slide nga akong gi-discuss sa inyo, kung natay ellipse, side view ta, no? Kung mao ni si z, no, z axis, and this one will be x axis. So mao nang instead of y nigamit ta og z, no? Next is we're going to differentiate, no? Differentiate the equation with respect to z, no? Ay, by the way class, this equation pala is we are going to denote this one as equation 0, no? And differentiate with respect to z, no, this equation. So again class, let important thing na ato ang kinahanglan masabtan is si A o si B is constant, no? Constant ang value ana niya. So therefore pag differentiate niya, ato ni siyang i-treat as a constant, si A o si B. So, differentiating the equation, mahimo na siyang 2x over a squared plus 2z over b squared dz over dx is equals to 0. So, atong manipulate ang equation nga mabili na lang diriya is ang dz over dx, no? So, therefore, ang kaning 2x over a squared atong i-transpose sa picas, no? So, mahimo na siyang 2z over b squared dz over dx is equal to negative 2x over a squared. No? Since gusto na ito mabilin, si dz over dx naman sa picas. No? So, mahimo na siyang 2x over a squared times, no? Kaya ito man siyang kuwan sa picas, no? Para mabilin na lang is ang dz over dx. So, negative 2x over a squared times atong siyang ibaliktaron, no, ang kaning 2z over b squared. So mahimo na siyang b squared over 2z. Manipulating, so ang mabilin na ang ato ng equation karon is mahimo na siyang dz over dx is equals to b squared negative b squared x over a squared z. So muna ni karon atong equation number 2. No? Take note of this one. So next is we are going to get the slope of this line, kaning line class kani. So in this part also we have here kaning line, equal na sila, laylay na sila og forma. So to get this, we all know that slope is also equal to the derivative of rise over the derivative of run or dy over dx. But in our case, since ato ang isa ka axis is z, so therefore dz over dx. No? And to get this ang kaninga slope of this line, no? So we need to get the angle kani kay kanatong gamiton nga angle for derivation for slope. So this is also equal to 90 degrees minus geodetic latitude. So therefore, to getting the slope, it is opposite over adjacent, so tangent, no? And also downward man siya ang ato ang line, so therefore ang ato ang slope is negative. Pero kung ang ato ang line is pasaka or increasing, na siyang forma class, mo nang positive ang slope, no? But since downward man siya, padulong paubos man siya, so therefore negative atong gamitan. Negative tangent the angle kani 90 degrees minus theta, that is equal to dz over dx. So dz over dx, remain ang negative outside. Tangent is equal to sine over cosine. So therefore, sine 90 degrees minus geodetic latitude over cosine 90 degrees minus geodetic latitude. So ato pagid siyang i-expand ug maayo, no? Bilin ang negative sa gawas, no? So double angle na identities, no? Like for example, sine parehas na sila ni class A minus B. No, identity na niya class. So as you all remember, sine of the angle A minus B. So sin cos cosine, di ba? Kana ang inyo nagdamdaman. Pag sin cos cosine, pag cosine cos sin, di ba? Or I don't know kung inga na inyong pagka-memorize before sa double angle identities. So since sine 90 degrees minus geodetic latitude, we can have sine of 90 degrees times cosine, no? Kay sin cos cosine man siya, no? Sine 90 degrees minus cosine geodetic latitude minus, dala na to ang minus na sine, cosine 90 degrees times sine geodetic latitude. Okay, sin cos sin. For cosine, mo na to siyang cos sin, no? For cosine 90 degrees times cosine geodetic latitude plus, dito na to ang sine 90 degrees times sine geodetic latitude. Okay, cos sin. Since 90 degrees, sine 90 degrees is 1, no? This is the value of 1, and cosine 90 is 0, no? And of course, the denominator, cosine 90 is 0. And sine 90 is 1. No? So, 1 na siya. So, mabili na lang niya. So, naman lang class. No? So, dz over dx, retain ang negative sign sa gawas. Cosine na lang yung nabilin kani. Line natin yung color. So, cosine na lang nabilin. So, muna siya. Cosine kay kani ma-0 naman ni siya, no? And kani pod is 0, no? Kay since cosine 90 is 0, ang mabili na lang pod is si sine sa ubos. So muna na po siya sine geodetic latitude. And cosine over sine is also equal to cotangent geodetic latitude, and remain si negative sign. This is now our equation number 2. Next is, we need to combine the equation number 1 and equation number 2. Okay, since ang ato ang kani silang duha ka equation na which is ang equation 1 and equation 2, naka-express sila into dz over dx. Alright, so kay naka dz over dx man silang duha, so ato silang i-combine. This is the equation 1 and this is the equation number 2. Alright. So, cosine geodetic latitude over sine geodetic latitude is equal to negative b squared over a squared x over z. No? So, we need to find the x, no, out from these equations na itong i-combine. So, therefore, cosine theta or cosine geodetic latitude over negative sine geodetic latitude times, i-transpose ni siya dito sa picas. No? Ang mabili na lang kay x o is kanya na lang si x o si z. So therefore, mahimo na siyang a squared over b squared times. Naka-times siya. Is equal to x over z. Ato silang i-multiply. So we have a squared cosine theta or cosine what do you call this one? Cosine geodetic latitude over b squared sine geodetic latitude is equal to x over z. And to find x na lang, no, ato ni i-transpose ito si i-cross multiply si z. So therefore, naatay x is equals to a squared z cosine geodetic latitude over b squared sine geodetic latitude. This is now our equation number 3. So we need also to find the value of z, no, or the equation of z. So balik tani nga equation ka ganina, which is ang ato ang i-combine ang equation 1 and equation 2, which is cosine geodetic latitude over negative sine geodetic latitude is equal to negative b squared over a squared x over z. So atong ibalhin no si or ato siyang manipulate ang equation. Ang mabili na lang diri is ang variables na lang, which is ang x ug ang z. So therefore, we have cosine geodetic latitude over negative sine geodetic latitude times a squared over negative b squared is equal to x squared over z, x over z rather, x over z. So since ato pa yun siyang i-manipulate, so mahimo na lang siyang ato ning i-times ning kaning equation. So a squared cosine geodetic latitude over b squared sine geodetic latitude is equal to x over z. So we need to get in terms of z. So we have z is equals to b squared. Ato man siyang i-transpose sa picas. So b squared x sine geodetic latitude over a squared cosine geodetic latitude. So this is now our equation in terms of z, and also the equation number 4. Alright, so next is ato nang isolve ang z coordinate. And to do that, we need to substitute the equation number 3 to equation 0. So equation 0 is x squared over a squared plus z squared over b squared is equals to 1. So this is the equation that we are discussed from the previous slide. And we have also equation 3, which is x is equals to a squared z cosine geodetic latitude over b squared sine geodetic latitude. So mo ni siya tong equation number 3. Then kani nga equation ato dong i-substitute dito sa equation 0. To do that, so we have now the equation a squared z cosine geodetic latitude over b squared sine geodetic latitude, all raised to the power of 2 or squared over a squared plus z squared over b squared is equals to 1. Manipulating atong sulod ni si squared or ato ni siyang i-squared ning equation kani nasa sulod. So therefore, we can have a raised to the power of 4 z squared cosine squared geodetic latitude all over b raised to the power of 4 sine squared geodetic latitude all over a squared plus z squared over b squared is equals to 1. Manipulating ato pag i-simplify ni diri nga part, so mahimo siyang a raised to the power of 4 z squared cosine squared geodetic latitude all over b raised to the power of 4 sine squared geodetic latitude times 1 over a squared. So since kay makancel na to ni si a squared, and dapat tayo a raised to the power of 4 dito, so mahimo na lang siyang a squared, a squared. So plus z squared over b squared is equals to 1. Next, ato ni silang i-simplify again, or ato ni i-times, kaya ato man gibungkag. So therefore, mahimo siyang a squared z squared cosine squared geodetic latitude over b raised to the power of 4 sine squared geodetic latitude plus z squared over b squared equal to 1. Simplify again, since kinasila common value or common variables, which is z squared over b squared, so ato siyang igawas itong koon siya nga multiple. So z squared over b squared times a squared cosine squared theta na lang mabilin, kay since si z nakuha man siya, and over b squared na lang, kay nasa gawas ang isa ka b squared sine squared geodetic latitude plus 1 equal to 1. Next, to continue from the sa last slide mo na itong last na discuss niabotaan ni nga equation sa last slide ni siya gikan. So since b squared, we have this identity b squared over a squared is equal to 1 minus e squared. So I guess ako nang gipa-solve or gipa-prove sa inyong problem set number 1. Pero kung wala, so you can freely solve or you can freely prove this one, no, sa inyong kung dili mo satisfied. Basta kay equal na sila, no? Identity na sila. So if b squared over a squared is equals to 1 minus e squared, we can say that a squared over b squared is equal to 1 minus e squared, no? And since natay a squared over b squared sa ato ang equation kani, natay a squared over b squared, so we need to substitute this value to this one, no? So therefore, if you're going to substitute this value kaning 1 minus e squared, i-substitute na to siya sa a squared over b squared sa atong equation, we can have z squared over b squared times cosine squared geodetic latitude all over 1 minus e squared sine squared geodetic latitude plus 1, and that is also equal to 1. Now, next is by mathematical manipulation, no, we have z squared over b squared. So simple fraction na pag-solve, no? So kung ano to ang ilahang greatest denominator, no? Or least common denominator kung sa fraction pa. So therefore we have 1 minus e squared sine squared geodetic latitude. Muna siya ang denominator, no? For numerator, we have cosine squared geodetic latitude plus 1 minus e squared sine squared geodetic latitude, and that is also equal to 1. No? Next is atong i-distribute ni si sine squared kani siya nga part, no? Alright, lang ang color. Ato ni substitute nga part or ato ning i-simplify pa or no, bungkago na to siya, I mean. So mahimo na siyang z squared over b squared times cosine squared geodetic latitude plus sine geodetic latitude, no? Kaya ato man siyang distribute, no? Kana siya nga part. So mahimo na siyang sine squared geodetic latitude minus e squared sine geodetic latitude all over 1 minus e squared times sine squared geodetic latitude, and that is also equal to 1. But since we have this mathematical identity that cosine squared theta plus sine squared theta is equal to 1, no? Sa inyo ng trigonometric identity. So review ninyo na class. So therefore, kani siya is equals to 1, no? So out from that, we can have this equation z squared over b squared times, no? Since kay 1 naman to siya, ito atong last time, ato ang kani siya nga part. So 1 man ni siya. So mo ni siyang naay 1 minus e squared sine squared geodetic latitude all over 1 minus e squared sine squared geodetic latitude, and that is equal to 1. Alright, so atong i-transpose sa pikas ang kaninga equation, atong ibalhin sa pikas, no? Para mabili na lang is z squared over b squared, no? So tungod kay mabili na lang si z squared over b squared, so mahimo na siyang z squared over b squared is equals to ang kani mabalin sa taas, so ang kani mabalin sa taas, so therefore 1 minus e squared sine squared geodetic latitude all over 1 minus e squared sine squared geodetic latitude. So out from that, no, para makuha nato si z, which is ang ato ang goal, si z nga part, so mahimo na siyang z is equals to b square root of 1 minus e squared sine geodetic latitude all over square root of 1 minus e squared sine squared geodetic latitude. Alright, so next is to continue pala, no? So mao ni atong last nga nakuha nga equation from the previous slide. And in geodetic coordinate system, the value of the z coordinates must be in terms of a, or must be expressed in terms of semi-major axis, which is a. So therefore, katong equation is naka in terms of b pa siya, or semi-major axis. So we need to express that in terms of A, or the semi-major axis. Alright, so to do that, ay sir, nga natuod sir nga naka-express siya sa semi-major axis. It's because usually ang gina-given sa problem is si A, no, dili si B. Usually ang ginahatag nga parameter is ang flattening, semi-major axis, and the inverse flattening, pwede pod. So usually ginahatag is si A or si semi-major axis. So that's why we need to express our equation in semi-major axis. Again, to do that, we have this identity in geodesy. B is times the square root of 1 minus E squared is equals to A times 1 minus E squared. No? Again, kung na-appeal na ko ni siya sa inyong prob set, then good. Pero ug wala, ato gyapon i-solve diri no, sa kani nga slide. Or pwede pod siya kani nga equation. Kani B over A is equal to 1 minus E squared all over square root of 1 minus E squared. Again, equal na sila anak, no? Parehas na sila. So, to prove that this is really equal, so ato siyang i-prove diri sa ato ang presentation, no? So from that, we can say that B times 1 minus, no, the value of eccentricity squared is equal to A squared minus B squared all over A squared. Again, ako na ko nga value from the previous topic nga atong gi-discuss na sa geometric geodesy. Raised to the power of 1/2, no, kay since is square root of 1/2 is equal to pwede na pod si A times 1 minus value of eccentricity squared, which is A squared minus B squared over A squared. No? So, doing mathematical manipulations, no, we can have B times A squared minus the quantity of A squared minus B squared all over A squared. So, gikuhaan na niya og common na value, which is ang A squared. Raised to the power of 1/2. No? Is equal to, because na pod si A times A squared minus the quantity of A squared minus B squared all over A squared. No? Again, mathematically manipulating, we have B times A squared minus A squared plus B squared all over A squared raised to the power of 1/2 is equal to A times A squared minus E squared A squared plus B squared over A squared. No? So since natay makancel diri kani si A squared minus A squared, makancel po ni si A squared minus A squared, and si A is makancel nato siya diri ang part sa right. So sa ubos pod nga naka A squared. So therefore A na lang mabilin sa ubos. No, diya nga part. So ang mabilin na lang is si B times B over A. Okay, since kay naka 1/2 siya tapos naka squared atong ubos, so therefore makancel ang ato ang exponent. So therefore may mo siyang B times B over A is equal to, sa pikas ang nabilin is B squared over A. So therefore equal sila, no? Equal si B squared of 1 minus E squared is equals to A times 1 minus E squared. Kay same sila sa ato ang pag-prove, ni come up sila sa equation nga B squared over A squared, no? Pareha sila ni come up with that equation. Therefore, na-prove nato, no, nga pareha sila, equal sila. So, gikan ani nga equation sa taas kani, no? Gikan ani nga equation, we can now say that the value of Z is A times 1 minus E squared sine geodetic latitude all over square root of 1 minus E squared sine geodetic latitude. So this is now the equation or the formula in calculating the Z coordinates of geodetic coordinate system. Next is to solve for X coordinate. And to do that, we need to substitute the equation number 4 that we have get or derive from the previous slides to equation 0. So this is the equation 0, which is the formula or general equation for an ellipse. And we have also equation number 4, which is z is equal to b squared x sine geodetic latitude all over a squared cosine geodetic latitude. So i-substitute nato ni siya kaninga value into this one. So therefore we have x squared over a squared plus si z, which is b squared x sine geodetic latitude all over a squared cosine geodetic latitude all over raised to the power of 2. Naka-squared siya. All over b squared is equal to 1. Next is by mathematical manipulations. So a squared nato ni nga equation kani diri nga part. So therefore we have x squared all over a squared plus b raised to the power of 4 x squared sine squared geodetic latitude a raised to the power of 4 cosine squared geodetic latitude all over b squared. That is also equal to 1. So ato ni i-simplify nga part diri nga kani nga equation or kani diri nga part lang. So mahimo na siyang x squared over a squared plus b raised to the power of 4 x squared sine squared geodetic latitude all over a raised to the power of 4 cosine squared geodetic latitude times 1 over b squared is equal to 1. But natay pwede ma-cancel since b4 base to the power of 4 mahimo na lang siyang squared kani is ma-cancel. So we have again next through mathematical manipulation we can have x squared over a squared plus b squared na lang base b squared x squared sine squared geodetic latitude all over a raised to the power of 4 cosine squared geodetic latitude, and that is also equal to 1. Then atong igawas ato ang igawas ang ilahang common variable which is ang x squared over a squared. Ato igawas siya sa pikas or ato siyang igawas sa equation. So mahimo na siyang x squared over a squared times 1 plus b squared ang mabili na lang siya is b squared sine squared geodetic latitude all over a squared cosine squared geodetic latitude, which is also equal to 1. Now, since again kanina pod na identity atong gamiton, which is atong gigamit kaganina na b squared over a squared is also equal to 1 minus e squared. So kani nga value again class kani is also equal to kanina. So namantay part nga parehas og dagway ato man na siyang substitute dira siyang i-substitute si 1 minus e squared. So we can have we can have x squared all over x squared over a squared times 1 plus atong i-substitute naman nato si 1 minus e squared. So we can have 1 minus e squared sine squared geodetic latitude all over cosine squared geodetic latitude. Again, it's all equal to 1. And through again mathematical manipulations, so ang gibuhat lang ani niya is gisa distribute lang siya diha distribute lang to si sine squared geodetic latitude. So we can have x squared over a squared plus times 1 plus distribute man siya, so nahimo na siyang sine squared geodetic latitude minus e squared sine squared geodetic latitude all over cosine squared geodetic latitude. Again, it's equal to 1. Right, so from the previous slide, we ended here nga kaning equation. So to continue, we need to get the common value, or to have a simple addition of fraction. Yan na siya ang concept. So mathematically manipulated, we can have this equation, which is x squared over a squared times cosine squared, cosine squared geodetic latitude plus sine squared geodetic latitude minus e squared sine squared geodetic latitude all over cosine squared geodetic latitude, which is ang iyang common nga value. Again, this is all equal to 1. And from this equation, we can say that cosine squared geodetic latitude plus sine squared geodetic latitude is also equal to 1. Diba? Trigonometric identity. So therefore, ang mabiling na lang is x squared over a squared times 1 minus e squared sine squared geodetic latitude all over cosine squared geodetic latitude. That is all equal to 1. So to get the value for x, atong ibalhin kaning part, balhin nato sa pikas para ang mabili na lang is si x squared over a squared. So we have x squared over a squared is equal to cosine squared geodetic latitude all over 1 minus e squared sine squared geodetic latitude. So kay x naman lang ato ang kuhaon, in terms of x, we can now have the x squared, that is also equal to a squared cosine squared geodetic latitude all over 1 minus e squared sine geodetic latitude. Square both sides, we can have square root both sides. We can have this x is equals to a cosine geodetic latitude all over square root of 1 minus e squared sine squared geodetic latitude. So this is now the equation or the formula for getting the x coordinate value of in terms of geodetic coordinate system. To summarize, here are the geodetic coordinates. For x, or in terms of x, we have a cosine geodetic latitude all over 1 minus e squared sine squared geodetic latitude raised to the power of 1/2, or that is equal to a cosine geodetic latitude all over square root of 1 minus e squared sine squared geodetic latitude. In terms of z, we have a times 1 minus e squared times sine geodetic latitude all over 1 minus e squared sine squared geodetic latitude raised to 1/2, or a times 1 minus e squared sine geodetic latitude all over square root of 1 minus e squared sine squared geodetic latitude. For the reduced latitude, or the derivation of the reduced coordinate system, so let's go back to this illustration on how to make an ellipse mechanically. First is we have a circle, a small circle, and another one is a big circle, nga gawas kibali siya sa small circle, and we have here the z-axis and the x-axis. Alright, side view yapon ta class. So from the illustration, we can have this radius, kani nga part. So and out from that, we can have a from the point of intersection of the radius sa small circle, padulong dito sa right side, and from the intersection of the outer circle going downward, maka-form siya of 90 degrees. And sa atong illustration before, sa katong how to make an ellipse mechanically, so naatoy mo natadtad dira nga mga kuano, katong gitadtad to siya og mga what do you call this one, basta marag sambot like radiuses, then create na po na to og 90 degrees, So nga naman atong discussion, di ba? Right? Then ato siyang i-trace, mahimo siyang ellipse, di ba? So out from this one, so we can create an ellipse, no? So muna siya. So kani nga angle, kani siya class, kani padulong diha. That's what we called a reduced latitude, di ba? From our previous discussion. And this yellow line, from tanaw na to siya sa ellipse, no? Focus mo sa ellipse. So kung kaning yellow line, this corresponds to the major axis, di ba? No, major axis kaning, I'll say my major axis kaning yellow. So labi na diri ang part sa ellipse. So, major axis. And to get this yellow part, kani nga part, yes, nara siya. From diri, padulong diri we can say that to get that value, we can use this equation na a cosine reduced latitude. Next is kaning red line. From inner siya nga circle. So, equal po da siya sa kanan nga part. So, to get the another part which is kani padulong diha, no? Itong i-project here ana, yes, kani siya nga value that is equal to b sine beta. So out from those illustration from the previous slide, we can say that the reduced or parametric coordinates is mo na ni siya, no? Si x, or in terms of x, we can have a cosine reduced latitude, and z is equal to b sine reduced latitude. Let's go now for the geocentric coordinate system. So for the geocentric latitude, from our previous discussion, mo na ang iyahang definition. It's the angle at the center of an ellipse between the plane of the equator and the line to a point. So padulong do sa center sa ellipse, and from the equator padulong sa line to a point. So let's say baliktaan nga naa diri ang ellipse. This is the x-axis, or z-axis rather. Another axis is the x-axis. And that yellow, kaning yellow is ang point or some point at the surface of the earth, no, nga gusto na to siya i-locate, no? So out from that, padulong do sa center sa ellipse, and from the equator padulong sa line of a point kana, no? So that is now the geocentric latitude. Next is we're going to derive the formula for coordinates of the geocentric coordinate system. So baliktaan nga figure, no, kaganina. From this figure we can say that x, no, is just since kay r man ni siya, r ni siya kani nga part, so, radius na sa earth, no, geocentric lang nga coordinate system. So this is radius r, kani nga line from the point nga imong gusto i-locate padulong sa center sa ellipse, that is r. So therefore x is equals to r cosine geocentric latitude. So this is now our first equation. Next is z is equal to r sine geocentric latitude, out from this figure. This is our second equation, and we can say that to get the r is just equal to square root of x squared plus z squared, or from the distance formula. This is now our equation number 3. So to solve, let us recall first the standard equation of an ellipse, no, which is x squared over a squared plus, since kay z man ato ang y-axis, so therefore z ato ang parallel siya sa y-axis sa 2-dimensional, so therefore z squared over b squared is equals to 1. So this is the equation number 4. So next step is we are going to substitute the equation 1 and 2 to equation 4. Asa man ang equation 1 and 2? So kani equation 1, equation 2, si x ug si z ato siyang substitute into equation 4 sa kani, no, sa standard equation of an ellipse. So kung substitute nato siya, may nganing forma, no, r cosine geocentric latitude squared over a squared plus r sine geocentric latitude squared over b squared is equal to 1. So kung ato siyang isulod ang squared, no, or ato siyang distribute, mahimo siyang r squared cosine squared geocentric latitude all over a squared plus r squared sine squared geocentric latitude over b squared is equals to 1. And igawas na to si r squared since kay siya common, no, sa ilang duha. Therefore mahimo na ang equation of r squared times the quantity of cosine squared geocentric latitude over a squared plus sine squared geocentric latitude over b squared is equals to 1. Then we are going to ato siyang kuhaon in terms of r. So dapat r na lang mabilin sa PCAS, no, dili sa left, and atong ibalhin ang kaning mga equations sa PCAS. I-transpose na to siya. Therefore mahimo siyang r squared is equals to 1 over cosine squared geocentric latitude a squared plus sine squared geocentric latitude over b squared. And ito ang kuhaon, no, ang ilahang common value, which is ang a squared of b squared sa denominator na side. So therefore mahimo siyang r squared is equals to 1 over b squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude all over a squared b squared. Then we're going to square both sides, and before we are going to square, ato sa i-simplify, no, ang equation nga diri ang part, which is mahimo siyang r squared is equals to a squared b squared all over b squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude. Then ato din siyang i-square both sides, square root both sides, square root both sides. So mahimo na siyang r is equals to ab over over square root of b squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude. To harmonize the previous coordinates with 1 minus e squared and a, no, same sa geodetic latitude, no, or geodetic coordinate systems, which is expressed in 1 minus e squared and dapat naka semi-major axis. So let us prove now that the given or the last nga equation yung ato na derive, which is kani na r is equals to ab over square root of b squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude must be equal with this value, no? So dapat ato silang i-prove nga parehas ni sila, no? Which is a times square root of 1 minus e squared over square root of 1 minus e squared cosine squared geocentric latitude. Alright, so mangutan mo nga nung kaniman, sir, no, anong kaniman nga value. So mahibaw-an na ninyo ni siya unya, no, pag later na ako nang i-summarize kung unsa ang value sa x coordinate, no, and z coordinate sa geocentric na coordinates, no. Okay, since diri nga part, no, tong time nga nag-derive ko ani class is na-stop ko diri nga part, no, na-stop ko diri nga part. So akong gibuhat is ako siyang gi-reverse, no. Akong gi-prove na ako na siyang gi-prove na more siya murag reverse ba, murag back substitution kumbaga, no, nga murag ang output or ang given na equation, no, nga naka-express na siya sa 1 minus e squared og a, no. Ako siyang gi-prove kung sa equal ba ni siya kang ab over b squared cosine squared or square root of b squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude. So karon nato i-prove, no. So out from this one, from this value, we can say that ma-express ito siya as in ani, no, like a times 1 minus e squared raised to the power of 1/2. Okay, since ang square root is ang power ana niya is yung exponent ana niya is 1/2. So as the denominator, which is 1 minus e squared cosine squared geocentric latitude raised to the power of 1/2. Then let's substitute the value for eccentricity squared. So mahimo na siyang a times 1 minus a squared minus b squared over a squared raised to the power of 1/2. And for denominator, we can have 1 minus a squared minus b squared over a squared cosine squared geocentric latitude raised to the power of 1/2. Alright, so next is from this last na itong equation, ito na pong bungkagon, no? We have this trigonometric identity, no? Nga cosine squared theta plus sine squared theta is equal to 1. So ato na siyang i-apply diri sa atong derivations, no? So since 1 diha so we need to atong bungkagon, no? Mahimo siyang cosine squared ang equation pala is mahimo siyang a times bungkagon na to ang 1 cosine squared geocentric latitude plus sine squared geocentric latitude minus a squared minus b squared over a squared raised to the power of 1/2. Same gyapon sa denominator, si 1 atong bungkagon, mahimo na siyang cosine squared geocentric latitude plus sine squared geocentric latitude minus, no, ato dayong i-distribute si cosine squared geocentric latitude kang a squared minus b squared over a squared. Mahimo na siyang minus times a squared cosine squared geocentric latitude minus b squared cosine squared geocentric latitude all over a squared. And this must be raised to 1/2. So next is ato siyang i-simplify ang denominator nga part sa tauna, denominator. So ato siyang ang iyang common value must be a squared, no? So ato siyang kuha ang common value. So a times a squared, no? Mahimo na siyang a squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude minus a squared plus b squared all over a squared. Okay, since ang iyahang common atong kuhaan og common value which is ang a squared. For denominator, same atong buhaton, no? Mahimo na siyang a squared cosine squared geocentric latitude plus, no, a squared sine squared geocentric latitude minus a squared cosine squared geocentric latitude plus, no, b squared cosine squared geocentric latitude. Out from that, so natay makancel sa denominator which is ang a squared cosine squared geocentric latitude, no? Makancel na siya. So out from that, no, naamay makancel, so ang iyang equation maing-ani na siya. A times, no, a squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude minus a squared plus b squared over a squared all over raised to the power of 1/2. So so the denominator pod, ang mabili na lang is ang a squared sine squared geocentric latitude plus b squared cosine squared geocentric latitude all over a squared and also raised to the power of 1/2. Next is, no, makancel si a, no, or si di ba kay nga part, no, so naay makancel diri since kay what do you call this one, kung ato siyang i-square root si a squared, ma-a na lang siya, no? And pag ato pong i-square root si a squared sa denominator, ma-a na lang po siya. So makancel siya, no? Makancel siya. So therefore atong equation, no, from this part, no, mahimo na siyang a times a squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude minus a squared plus b squared raised to the power of 1/2 all over, kay since lagi square root of a squared is a na lang, so mo na ay a diri class, all over sa denominator po mahimo siyang a squared sine squared geocentric latitude plus b squared cosine squared geocentric latitude raised to the power of 1/2. And since a squared, square root of a squared is a, so makancel ni si a, no, na part. Ang mahitabo, maing-ani na siya. So ang denominator na lang mabilin is a times a squared cosine squared geocentric latitude plus a squared sine squared geocentric latitude minus a squared plus b squared raised to the power of 1/2. For denominator, we have a squared sine squared geocentric latitude plus b squared cosine squared geocentric latitude raised to the power of 1/2. Afterwards, no, atong kuhaan og common value, no, atong igawas si a squared, no, from this equation, no. So a nga sa gawas times atong igawas si a squared since kay common sila na a squared na a squared, na a squared. Or dire lang apart, dire lang apart. So therefore, atong igawa si a squared, may mo siyang a squared times cosine squared geocentric latitude plus sine squared geocentric latitude minus a squared plus b squared raised to the power of 1/2. All over a squared sine squared geocentric latitude plus b squared cosine squared geocentric latitude raised to the power of 1/2. But since kaning si cosine squared geocentric latitude plus sine squared geocentric latitude ato man gibungkag ganina, so ato lang ibalik. No? Therefore, mo 1 ni siya, 1 kay identity, no? Trigonometric identity. So mo 1 na siya. Atong equation mahimo na siyang ingani, no? A squared times a times a squared, so mo 1 naman ni. So minus a squared plus b squared raised to the power of 1/2. All over denominator nga a squared sine squared geocentric latitude plus b squared cosine squared geocentric latitude raised to the power of 1/2. Next thing is, since makancel man si a squared minus a squared, no, ang mabili na lang is a. So ang mabili na lang diri kay di ba b squared na lang kay makancel na si a squared ug si a squared. So b squared na lang. So b squared, square root of b squared, b na lang, no. Mao nang ang mabili na lang sa equation is maing-ani a b over square root of a squared sine squared geocentric latitude plus b squared cosine squared geocentric latitude. Therefore, na-prove nato, no, na equal di ay tong ato ang gihatagay nga equation. So therefore, si r di ay, no, or ato ang r is ingani na ang equation. Eh di ba since mo na itong nakuha gay na nga last na equation, no, kani dinato siyang i-prove nga ma-equal siya ani, no, para ma-harmonize, no, nga na ay 1 minus e squared of ang iyahapong isa ka parameter nga available is ang a, which is ang semi-major axis. So therefore, r is also equal to a times square root of 1 minus e squared all over square root of 1 minus e squared cosine squared geocentric latitude. Kaya na-prove na to, no? Na-prove na to nga equal sila. So this will be now our equation number 5. And to solve for x coordinate, no, let's substitute the equation number 5 to equation number 1. This is the equation number 5. Nakuha kanina bago lang. And this is for equation number 1. Atong i-substitute ra si r. So we can have now x to be a times square root of 1 minus e squared. Dugangan na nato og cosine. Cosine geocentric latitude all over square root of 1 minus e squared cosine squared geocentric latitude. And to solve for z coordinate, no, let's substitute the value of equation 5 to equation 2. So this is the equation 5, ani class, and this is the equation for 2. So substituting, no, the 5 to 2, you can have z is equals to a times square root of 1 minus e squared sine geocentric latitude all over square root of 1 minus e squared cosine squared geocentric latitude. So muna ni karon ang mga coordinates sa geocentric latitude. Another way of expressing. Let's say, muna ni siya, no? X is equals to a times 1 minus e squared. So since kay square root man, so pwede na dyan po siya ma-raise into 1/2 cosine geocentric latitude all over 1 minus e squared cosine squared geocentric latitude raised to the power of 1/2. For z, we have a times 1 minus e squared times 1 raised to the power of 1/2 sine geocentric latitude all over 1 minus e squared cosine squared geocentric latitude raised to the power of 1/2. So to have the relationship between those latitude, we're going to use the equation that was previously derived, no? Provided and also derive na to ganina from geodetic coordinate system and reduced coordinate system, and lastly atong bago lang is ang geocentric coordinate system to obtain the relationship between these latitudes. So we have z over x, which is slope, z over x or rise over run. So this is the equations, no, nga ito na-derive ganina. This is for geocentric, no, kaninga part. This is for reduce, and this is for geodetic, no. So we have z for geocentric, a times 1 minus e squared raised to the power of 1/2 sine geocentric latitude over 1 minus e squared cosine squared geocentric latitude raised to the power of 1/2. For x, we have a times 1 minus e squared raised to the power of 1/2 cosine geocentric latitude all over 1 minus e squared cosine squared geocentric latitude raised to the power of 1/2. For reduce, for z coordinate, we have b sine reduced latitude, and for x is we have a cosine reduced latitude. And for geodetic coordinates, no, for z we have a times 1 minus e squared sine geodetic latitude all over 1 minus e squared sine squared geodetic latitude raised to the power of 1/2. And for x coordinate, we have a cosine geodetic latitude all over 1 minus e squared sine squared geodetic latitude raised to the power of 1/2. So, na ay makancel. So, may makancel, sir. First is ang kana, no? 1 minus e squared, and also that one. No? Makancel siya. Next is, so pa may makancel. Again, ang denominator, makancel. Denominator, makancel. Another one, makancel pod sa ang a sa geodetic latitude or geodetic coordinate system, so as sa x na part, makancel si a. And makancel pod ang denominator, no, sa geodetic coordinate sa z, also sa x, makancel siya. So therefore, ang mabilin na lang is kani, no? Balik ta. Anong si mabilin, no? Sine geocentric latitude or over cosine geocentric latitude. So that's tangent, no? Sine over cosine is tangent. Again, for this one pod sa reduce, sine over cosine is tangent. Diri pod, no, sa geodetic, no, sine over cosine tangent. Therefore, kani ang mabilin. Yan. So we have now this relationship between three latitudes. Tangent geocentric latitude is equal to b over a tangent of reduced latitude is also equal to 1 minus e squared times tangent of geodetic latitude. Or it can also express in this one. No, diba? Tangent geocentric latitude is equal to b over a, no, in terms of b over a. B over a tangent of reduced latitude is also equal to, since 1 minus e squared is also equal to b squared over a squared, no, ato nang gamit kanina sa pag-derive. So pwede siya ingani, no? Ang kaning 1 minus e squared can be expressed in this one, b squared minus a squared, para kung given mo og a o b lang, makuha na din mo ang relationship nila tulo, no? B squared over a squared tangent geodetic latitude. Or you can also, again, you can also use this in terms of eccentricity, no? Kung eccentricity lang ang gihatag, no, maka-calculate na din ka og relationship between the, makompute na din mo ang another latitude, latitude, given lang ang eccentricity. So you can also express in this way, no? Tangent geocentric latitude is also equal to, since b over a is equal to square root of 1 minus e squared or 1 minus e squared raised to the power of 1/2, so pwede siya. Tangent of reduced latitude is equal to 1 minus e squared tangent of geodetic latitude. So I guess nasabtan na niyo class, no? So mora po di importante ang ilang relationship between the latitudes. Alright, so let's have an example. Using the Clark 1866, A to be 6378 206.4 and B is 6356583.8. Calculate the following. First, we need to calculate the geodetic latitude given ang geocentric latitude nga 15 degrees. Number 2, we need to get the reduced latitude given the geocentric latitude na 45 degrees. And third is we need to calculate the geocentric given the reduced angle, reduced latitude niya 30 degrees. Alright. To solve for number 1, we have this equation, di ba? Itong relationship between the three tangent. And we can also express in this one, pwede sa b over a, pwede po 1 minus a squared. Since itong given is b og a, so kani nga formula itong gamiton. Suitable siya. No, kani nga formula. Kaya atong given is we need to get the geodetic latitude given ang geocentric latitude. So therefore, para makuha nato si geodetic, ato siyang ibalhin lang, i-transpose si b squared over a squared sa picas. So mahimo na siyang a squared over b squared tangent geocentric latitude is equals to tangent geodetic latitude. Substitute the value, no? A is 637,806.4 squared all over B is 635,658.8 squared. Tangent gihatag given is ang geocentric, which is 15 degrees, and we can calculate now the tangent geodetic geodetic latitude. So we can have now, no, using the calculator, no, we can have the value of geodetic latitude to be 15 degrees, 5 minutes, 51.25 seconds. So dapat, no, and also ang kaning si geodetic is dako siya, no, dako siya value compared sa geocentric, which is ni satisfy sa ato ang important note nga atong i-discuss kaganina nga si geodetic must be greater than or less than to reduce, and also si reduce is greater than or less than sa geocentric. Since atong ipangita kay geodetic man, no, and they come up nga sa ato ang nakuha nga answer, mas dako si geodetic, no, compared kang geocentric. Therefore, check, no, or na-check nato nga sakto atong answer. For number 2, no, balik ta ani nga mo ni ato mga formulas, no. And again, since kay b ug a ato ang gihatag ang given, so kani nga formula ang mas suitable. So we have, no, b over a tangent beta is equal to tangent geocentric latitude. Since kay ang gipangita kay tangent of reduce or ang reduced latitude ang gipangita, so we need to transpose b over a sa picas. So mahimo na natong equation nga tangent of reduced latitude is equal to a over b tangent of geocentric latitude. Then substituting the value, no, we can have tangent geocentric latitude, tangent reduced latitude is equals to 637,806.4 substitute over 635,658.3.8 tangent of ang given nga geocentric is 45 degrees. So it result to reduced latitude to be 45 degrees, 5 minutes and 50.22 seconds, no? And it shows nga mas dako si reduce compared kang geocentric. Atong i-check kung sakto ba. Yes, no? Mas dako dapat si reduce compared kang geocentric. Therefore, check ang atong answer. For number 3, no? For number 3 sa sample number 1. No? So for solution, again, balik ta ani nga equation, no? Ang atong gamiton is kaning sa babaw kay b ug a ang gihatag sa problem. So we have tangent geocentric is equal to b over a tangent reduced latitude. Since ang gipangita kay ang geocentric given ang reduce, substitute the value 635,653.8 over 637,806.4 tangent, ang given is 30 degrees nga reduce. We can have the value for geodetic to be 29 degrees, 54 minutes, and 56.96 seconds. So it shows nga mas dako si reduce, no? Reduce latitude. Atong i-check kung sakto ba. Alright, so mas dako gyud dapat si reduce compared kang geocentric. Therefore, check ang atong answer. Alright, so example number 2 na ta. Hapit na ta mahuman class. Example number 2. A spheroid has a value of A 6475000 and na siya given na B na 6350301. The problem is, or ang gipangita is, determine the geodetic latitude of the place whose geocentric latitude is 15 degrees and 30 minutes. To solve that, no, since kay ang gihatag nga given is B ug A, so balik ta ani nga equation. No. So given is ang gipangita nga ang angle nga involved is, or latitude nga involved is si geocentric and si geodetic. So ato siyang kuhaon na kaninga tangent geocentric latitude is equals to B squared over A squared tangent geodetic latitude. No? Since ang gipangita kay si geodetic latitude given ang geocentric, atong i-transpose ang B squared over A squared sa picas. So we have now the formula A squared over B squared tangent geocentric latitude is equal to tangent of geodetic latitude. Substitute the value, no, sa A and B nga given, which is 6475000 squared over 6350301 squared. Tangent, ang given nga geocentric latitude is ang 15 degrees and 30 minutes, is equal to tangent geodetic latitude. Calculating using your calculator, we can have geodetic latitude is equal to 16 degrees, 5 minutes, and 0.55 seconds. It shows nga mas dako si geodetic compared sa geocentric latitude. Atong i-check kung sakto ba. So it shows here nga mas dako gyud si geodetic latitude compared kang geocentric. Therefore, check ang atong answer. So for example number 3, no? We have the geocentric latitude of a point is 60 degrees and 20 minutes north in an ellipse having the value of A to be 6475000 meters and B to be 6350301 meters. Calculate the following. A. Geodetic latitude. B. The x coordinate using the geodetic latitude. C is the reduced latitude, and D is the x coordinate using reduced latitude. To solve, since ang given nato is B ug A, so this is the suitable equation. And involved na latitude is si geocentric and si geodetic. So i-crop na to ang part na geodetic ug geocentric lang. So we can say that tangent, kasi ang gipangita kay tangent geodetic latitude, i-transpose na to ni si B squared over A squared kang geocentric latitude. So therefore atong equation mahimo na siyang A squared over B squared tangent of geocentric latitude is equals to tangent geodetic latitude. Substitute the value, no? A and B, 6475000 squared over 6350301 squared. Tangent, given nga geocentric latitude is 60 degrees and 20 minutes. That is equal to tangent geodetic latitude. To get the value, or using your calculator, you can have geodetic latitude to be 61 degrees, 16 minutes, 55.53 seconds. And let's check, okay, sa nakita na to, see, from the given geocentric, no, mas dako si geodetic latitude compared kang geocentric. So ato ang i-check diri So tama, no? Mas dako si geodetic gyud compared kang geocentric. Therefore, check siya. Next, for B, no, atong i-calculate ang pangutana, no, which is the calculate daw the x coordinate using geodetic latitude. So, out from our derivations, no, sa atong previous slide, we have x is equals to a cosine geodetic latitude over 1 minus e squared sine squared geodetic latitude all over raised to the power of 1 half. So, since kaya ang gihatag sa tuwa is a o b, no, and ato ang formula is given ang sa atong formula is na ay eccentricity, no, kani si eccentricity. Therefore, ato sa siyang kuhaon, no, or makuha naman dyan siya sa eccentricity using the semi-major axis and semi-minor axis. So, eccentricity is equals to square root of a squared minus b squared over a. Substitute the value of a and b, no, atong given kaganina. So we can have the value for eccentricity to be 0.1953104,568. Then substitute, no, kay na naman tay a, given naman na natay geocentric, geodetic latitude, and we have also now our eccentricity. Ito siyang i-substitute. So, yan na ang equation na to. 6475000 cosine 61 degrees, 16 minutes, and 55.53 seconds. All over 1 minus eccentricity is 0.1953104,568 squared, no? Since kinaka-squared ang ato ang eccentricity. Sine squared 61, no? 61 degrees, 16 minutes, and 55.53 seconds. Raised to the power of 1 half. So therefore, we can have the value of x to be 3157891.835 meters. So muna yung answer sa letter B. So for C, no, ang ato ang puhaon is ang no, ang involved na latitude is ang geocentric o ang reduce, no. Kaya ang gipangita man is ang reduce, no, reduce na latitude. Out from this one, balik ta ani. So kay given one si B o si A, so kani ang suitable na equation. So in terms of reduce and geocentric, we can have this formula: tangent geocentric is equals to B over A tangent reduce latitude. Since kay reduce latitude atong gipangita, i-transpose na to si B over A kang tangent geocentric. So we can have this value, or we can have this equation, no? A over B tangent, ang given is 60 degrees and 20 minutes. So is equal to tangent reduced latitude. Substitute the value of A and B, 6475000 over 6350301, tangent of 60 degrees and 20 minutes equals to tangent beta. So calculating using your calculator, you can have the value of beta, or the reduced latitude, is equals to 60 degrees, 48 minutes, 36.47 seconds. So it shows nga mas dako si reduced latitude compared kang geocentric latitude. Atong i-check, no? So sakto, no? Mas dako gyud dapat si reduced compared kang geocentric. Therefore, check atong answer. And for D, no, sa D, no, ang ipangita is calculate the x coordinate using the reduced latitude. So mo ni ato ang formula. X is equals to A cosine reduced latitude. Substitute the value of A, which is 6475000, cosine reduced latitude nga itong nakuha ganina, which is 60 degrees, 48 minutes, 36.47 seconds. Therefore, ang atong value sa x is equals to 3157891.875 meters. Alright, so that ends our part 1 of the topic 3 for geometric geodesy. And I hope nga nakatabang ni, no, sa inyong pag study, no, about about the this one, the latitudes, and all over nga itong discuss from this topic. So, um, sa mga questions ninyo and clarifications with this topic, no, you can freely ask me through our Facebook page, no, sa Facebook page nako. No, again, please class, ayaw mo PM sa ako kay naiusahay labi nagdelete ta friends, no. Dili ko usually katanaw og kanang message request, no. So therefore, na tendency nga di na ako mabasa, no? Basin importante ang inyong pangutan na di na ako dahil matubag, no. So while sa FB, no, sa FB page mo notify man dayon siya sa ako no, na ay nag-message sa FB page. So ma-answer din ako ang inyong questions. So mas better nga dito mo, no, dito mo mag-ask of question instead of PMs or sa my personal account. No, again, sa inyo pong pag-ask of questions and clarifications, be sure class nga nag-study na mo, no, or nana mo na sabtan na natanaw na ninyo nga video, na basa na ninyo ang PDF nga akong gisend, no, para mas mo deep in pa to ang what do you call this one? Mas mo deep in pa to ang discussion, okay? Ang mga basics, no? The basics of this topic is na naman diri sa slides, na naman sa atong video lecture ako naman gi-discuss. So, mangutan na mo kato nang wala ninyo sabtan or wala diri sa slides, no? For further learnings ninyo. Okay, nausahay man gud na same lang og question sa mga students, same lang og question, and ang answer is naara diri sa video lecture, naara sa atong slides, no? So ingana nga mga ingana nga mga tendency, no? So be sure nga nag-study na mo, no? You've done your part, no? Then after kung wala pa gid mo nakasabot, then sa ako na din mo approach, ingana, no? So that's it for topic 3 part 1, and also this is the last part for midterm coverage, no? And I'm going to schedule, no, kung panos ato ang midterm exam. So tentative is akong gihimo is 20, no, November 20. So study this lecture, video lecture, and sa PDF also, and mag-ingon lang ko kung extend or ma-reschedule ang ato ang midterm exam. See you in our next video class, and keep safe, God bless, and have a good day.